Now we're going to complicate the aggregate expenditure model. We'll add back some of these components of aggregate demand. Previously, G, T, X, M, they're all set to 0. Now we're going to let them be non-zero. Start with G, government spending. What determines government spending? By and large, the whims of politicians. I'm perhaps informed by some degree to the preferences of voters, but how much or to what degree, that's a whole other field. Politicians set priorities and make choices to spend certain amounts of money. It's not entirely random. We can discern some patterns. Some government spending is counter-cyclical. If the economy gets a little worse, then government spending will go up. That comes from automatic rules put in place through policies like unemployment insurance. More people lose their jobs and they'll file for unemployment benefits, and so government spending will go up when GDP goes down. Vice versa, if the economy is doing well, then government spending will decline a bit. Taxes, on the other hand, are cyclical. When the economy is doing well, then people get paid more and tax collections go up. When the economy is doing poor, then people get less money in their paycheck and tax collections go down. I'm not saying tax rates, I'm saying tax collection in total. If you get a raise, good news, but the government's going to take their bite. They're going to get a little more money out of you. Not for moving to a new tax bracket or something, just taking the same percentage from a higher wage. When GDP goes up, the government's going to collect more taxes. When GDP goes down, the government's going to collect less taxes. But that has the effect of stabilizing the economy. Considering exports and imports, X and M in our notation, both of those depend on exchange rates, which we label FX, foreign exchange. Exchange rates depend on a whole ton of different things, including things like interest rates in different countries, relative economic conditions, and global macro events. Imports also depend on consumption patterns here, since wealthier people might buy more luxury goods from overseas. But, to keep this model simple enough, we start by assuming these new variables are exogenous. Exogenous is just a fancy word that means determined outside the model. That's exo, outside, not endogenous. They're not endo within the model. They're exo. Investment, I, depends on business confidence and interest rates. Government spending, G, and taxes, T, depend on politicians' policies. Exports and imports, X and M, depend on the rest of the world economy and FX rates. We have all these bits, but none of them really depend on potential GDP. From our previous talk on aggregate supply and aggregate demand, I noted the intersection of those short-run curves did not depend on potential GDP. That's informational, but it's not related to the equilibrium. And that's true for the more complicated models as well. In the short run, economy goes up, economy goes down, but it may or may not have much to do with the true level of potential GDP or the true or long-run value of unemployment. So here's a slightly more complicated version of the expenditure output model. We keep the linear equation for C. So C is A plus B times Y minus T. So consumption is a simple linear function of disposable income. We're going to model that taxes depend on income. We'll start with, a simple linear model of that. So taxes are T naught, level of autonomous taxes, plus little t times Y. Little t is the tax rate. As Y goes up, tax collected goes up as well. That's the marginal tax rate. This is an overall average for the economy. When April 15th comes up, you do your own taxes, your tax collections are a little more complicated. But this simple model will suppose it's nice and linear. For now, we'll keep the other variables I, G, X, M to be all set at some level which is exogenous, determined outside the model. Yeah, the terminology is kind of boring, I apologize, but it's complicated enough. Then we do some steps of algebra. Put each of the first equations into that last definition of aggregate expenditure and simplify. Y equals aggregate expenditure, that's our fundamental equilibrium condition. Substitute in. Aggregate expenditure is C plus I plus G plus X minus M. Substitute in each one of those. C is A plus B times Y minus T. T itself is T naught plus little ty. So that gives us a fierce set of brackets. Then I naught plus G naught plus X naught minus M naught, distribute those through. Be careful of all the negative signs. Be careful about multiplication across the parentheses. But with a bit of rearranging and some care, we get y equals a plus by minus bt naught. Note the b is distributed through to the minus t naught. Then minus b times little t times y, again, because that little b is distributed through the minus sign. Then that plus I naught plus G naught plus X naught minus M naught. Let's see here. I'm lost. Where are we? Collect terms involving y on the left-hand side. We have y minus by plus bt. Again, careful that the b terms switch signs as they go across the equals. Sign goes from minus bt on the right-hand side to plus bt once it's on the left-hand side. All the y terms equal a minus b t naught plus I naught plus G naught plus X naught minus M naught. Take out the y on the left-hand side, form y times 1 minus b plus bt. That equals the same collection of terms. Divide through by the coefficient of y, so the equilibrium value of y is 1 over 1 minus b plus bt, multiplied by all that remaining stuff. A minus b t naught plus I naught plus G naught plus X naught minus M naught. The multiplier is changed. It's one of the key things we want to note. Now it's 1 over 1 minus b plus bt. And we can play with parentheses, rewrite it as 1 over 1 minus b times another parenthesis, 1 minus t. But, if b is something like 0.8 and t is something like 0.3, then the multiplier, instead of being 5 as in previous example, now would be just 2.27. Any change to a or I naught or G naught or X naught or M naught has the exact same multiplier. Changes to t naught have a smaller multiplier because of the additional b term there. We'll go into more detail about that later. As we get into more complex models, we'll see the value of the multiplier can be changed around.